All right, so this is going to be a quick video for pages 18 and 19 on the Kinematics 2 packet. Okay, so we're just going to start off by going over the 5 kinematic equations. So your first column, it says your equation number. That just means which equation we're going to be using. Your second column says unused/missing variables. That means whenever we give you a word problem, there's always going to be one that they don't mention or we're not using. Okay, so that's going to tell us which equation to use. And then our equations, we're going to write those down. So our first equation is going to be your final velocity equals your initial velocity plus acceleration times time. Okay, so VF equals VI plus AT. Number 2, okay, that's going to be displacement equals our VI, our V initial, plus our V final, VF, all over 2, and we're going to multiply that by time. Okay, and we will give you these equations. You do not have to memorize them, so we're just writing them down. Third equation, so if VF is not used, this would be the one we're using, and we'll do a lot of practice in the upcoming video. So our third equation is going to be our displacement equals our initial velocity, so VI times T, our time, plus 1/2 AT squared. So 1/2 times our acceleration times time squared. Now, just be careful with this. The only thing that is squared is time. Okay, do not square the whole thing. The only thing that's squared is time. Now, our equation number 4 is going to be almost look like the same thing. It's going to be displacement equals VFT minus 1/2 AT squared. And then our last equation, if time's not mentioned or they don't ask for it, is going to be VF squared, so V final squared, equals V initial squared plus 2AD. Now, kinematic equations are only used to solve problems for uniform acceleration, so we're not going to worry about changing acceleration right now. So we're going to keep acceleration the same. This next part is just review on what do the abbreviations mean and what are their units. So if you're having trouble with that, make sure you take a look at that. Take a look at this table to look and see what units go with what and what letter means what. Okay, so I just gave you those 5 equations, but if I don't give you anything like let's just say there's no acceleration. Let's just say I give you velocity is 7 meters per second, and I give you displacement is 5 meters, and I'm looking for time. Okay, if there's only those 3 things, don't think that we had to go up here and use these big elaborate equations, okay, when I know that V equals D over T. Okay, so this equation right here still exists. We're just kind of taking a pause from that. We're just adding more to it. Okay, so if I give you 2 of those, like V and D, all you have to do is use V equals D over T. You do not need to come through here and use all these equations here. Okay, so we're going to do some examples, and then that'll be it for this video. We're going to do more on the next video. So this is just a basic, get you started. So a ball rolls downhill with an acceleration of 2 meters per second squared. If the ball starts from rest, what is the velocity at 4 seconds? So the way we're going to do this is we're going to set up, it's called Daffy T. So dA, VF, VI, and T, which pretty much looks exactly like up here on our equations. We have Daffy T. Okay, so 1, this helps you organize what you have, and 2, this will help tell you which equation you're going to use. So a ball rolls down the hill with an acceleration of 2 meters per second squared. So my A is 2 meters per second squared. Okay, if the ball starts from rest, so from rest means something's got to be 0. And if you're starting from rest, that means your initial velocity is going to be 0 meters per second. And then what is the velocity at 4 seconds? So my time is 4 seconds. And I want to know what is the velocity. So VF is my question mark. So they did not mention displacement or distance at all. So I'm going to put a big line through that. Now, whichever one they don't mention, that's the equation we're going to use. So if they don't mention D, we're going to go up here to our equations, and we're going to use the equation for D right here. Okay, so really important that you get this. It's not the equation you're looking for, so we're looking for VF. That does not mean I'm going to come up here to VF and I'm going to use the VF equation for this. I'm not going to use that. I'm going to use the one we're not mentioning. So we're not mentioning displacement, so we're going to use equation number 1, which is VF equals VI plus AT. So VF, we don't know. I'm going to leave it as VF. VI is going to be 0 plus A, which is our 2, and time is 4. Okay, so this is a very basic question. So 2 times 4, that's going to give me a final velocity of 8 meters per second. And there's your answer. Okay, so nothing too difficult. It's just labeling down what you have, writing down what you have, and then just figuring out what you're looking for and which one they don't mention at all. So B, we're going to keep going. Okay, so it says, how far did the ball travel during this time? So I'm going to do my Daffy T again. Now, distance is what we're looking for now because I want to know how far did it go. Acceleration is still 2.0 meters per second squared. Okay, now you could use V final that you just found, but I always recommend just use the information that we gave you originally in the problem. One reason is if you messed up on part A and you did not get 8 meters per second, and you bring that answer down to part B, now that creates a domino effect that's going to mess up part B. So VI, I'm going to stick with that 0 meters per second because they told me it started from rest. And I'm going to stick with the time because they want to know how far did it go in that 4 seconds. So what I'm going to do is I'm not going to care about final velocity at all. So I'm going to put a big line through it. So now I'm going to come up to this equations. And now I get to use equation number 3. I'm going to use the one they don't mention at all. Okay, I'm not using the one we're looking for. So now I'm not going to use equation number 1. I'm going to use equation number 3. Okay, so I'm going to come back down here. So my equation, D equals VIT plus 1/2 AT squared. Okay, now D I don't know. That's what I'm looking for. I'm going to leave that as D. Now the good news is VIT, if VI is 0, I can mark off that whole VIT because it doesn't even matter what T is. If it's going to multiply by 0, it's just going to be 0. So D equals 1/2 A, which is still 2, times time squared, so 4 squared. So again, be careful. The only thing we're squaring is that 4. So if we did our math correctly, that's going to come out to be 16 meters. And the next video is going to have a lot more examples on that. This was just kind of a basic get you going for the 5 kinematic equations.